intensity at O. So what is the basic formula we can apply now? So if you see this, intensity is equal to, so first let me call that as point P1. I P1 I'll call it. So that should be equal to I max into cos square pi by 2. This should be equal to how much it is. So here he has put a condition. First case lambda 1, no? This is corresponding to lambda 1. So this should be equal to cos square pi by 2. So this is how much has given 75%, 0.75. So shall we solve for cos phi 75, 0.75, 3 by 4. So this will be root 3 by 2. So phi equal to how much? 30 degrees. Or pi by 6 is the phase angle. Pi by 2, sorry, pi by 2. So this will be pi by 3 will come, the phase angle. So the phase angle 1, you write it. Then what will be the path difference of the rays arriving there? Can you remember this formula? So we know this phase angle, pi by 3. So there's a lambda and there's a path difference. So what is the path difference now? Delta x1 equal to lambda 1 by 6. Similarly, shall I directly write similarly for next thing? When the wavelength is lambda 2, so this should be equal to how much he has given? 0.5, 50% it will become. So 50%, 50 by 100, 0.5. So solving this, I'll get the phase angle phi 1. No, the phase angle phi 2 will be equal to pi by 2. Then the path difference, phi 2 equal to 2 pi lambda delta x2. So this will be pi by 2, 2 pi lambda 2 into this one. So what is delta x2? Delta x2 will be lambda 2 by 4. What was our question that is asked here? Find the ratio of lambda 1 by lambda 2. How to bring ratio? So what is use of this? What shall I do with this? Some quantity we have brought it. So is that what will be the path difference of the rays? So it should be equal to, so if you look at this rays, no, here. What will be the geometricals? The point P position, will it change? No, the point P will be there only. I think you must read. You must read this question. So most of you, what will happen? What you do is like you'll try to change. You'll try to think that there'll be change in position. So that the position of a point on a screen will not change. So what is changing? Only the wavelength is changing. So definitely, what will be the delta x1? Shall we say like a geometrical path difference? Geometrical path. So here I'll put it in this way. You can see this. What is delta x? So this will not change, no, as you change wavelength, because the position of slit has not changed. The position of point P has not changed. So definitely what you expect delta x should not change. So therefore delta x1 equal delta x2. So now write lambda 1 by 6 equal to lambda 2 by 4. I think that this what he has asked a question of like this. Can be asked, you can say simple idea. So I seen maximum you start thinking what to do with the delta x1 and delta x2. It's a geometrical path difference. The distance between the slit S1 and P has not changed, between S2 and P has not changed. You are going to change only the wavelength here. So this geometrical path difference will remain same. So therefore I should equate. Now, some good questions will be there. So you have to read question carefully here. If it says some other point, instead of point P says point Q, then we should able to find out delta x1, delta x2. Getting the idea? So you can twist further this thing. So instead of point P, if we say Q, so that, or P dash, the P dash lies here, no, then we should suppose to calculate delta x1, delta x2. Then we can do something here. Yeah.